Hi, I'm Daniel Walden. And welcome to Science News. Albert Einstein is widely regarded as a genius, but how did he get that way? Many researchers have assumed that it took a very special brain to come up with the theory of relativity and other stunning insights that form the foundation of modern physics. A study of 14 newly discovered photographs of Einstein's brain, which was preserved for study after his death, concludes that the brain was indeed highly unusual in many ways. But researchers still don't know exactly how the brain's extra folds and convolutions translated into Einstein's amazing abilities. The story of Einstein's brain is a long saga that began in 1955 when the Nobel Prize-winning physicist died in Princeton, New Jersey, at age 76. His son Hans Albert and executor Otto Nathan gave the examining pathologist, Thomas Harvey, permission to preserve the brain for scientific study. Harvey photographed the brain and then cut it into 240 blocks, which were embedded in a resin-like substance. He cut the blocks into as many as 2,000 thin sections for microscopic study, and in subsequent years distributed microscopic slides and photographs of the brain to at least 18 researchers around the world. With the exception of the slides that Harvey kept for himself, no one is sure where the specimens are now, and many of them have probably been lost as researchers retired or died. Over the decades, only 6 peer-reviewed publications resulted from these widely scattered materials. Some of these studies did find interesting features in Einstein's brain, including a greater density of neurons in some parts of the brain and a higher than usual ratio of GLIA, cells that help neurons transmit nerve impulses to neurons. 2 studies of the brain's gross anatomy, including one published in 2009 by anthropologist Dean Falk of Florida State University in Tallahassee, found that Einstein's parietal lobes, possibly linked to his remarkable ability to conceptualize physics problems, had a very unusual pattern of grooves and ridges. But the Falk study was based on only a handful of photographs that had been previously made available by Harvey, who died in 2007. In 2010, Harvey's heirs agreed to transfer all of his materials to the U.S. Army's National Museum of Health and Medicine (NMHM) in Silver Spring, Maryland. For the new study, published today in the journal Brain, Falk teamed up with neurologist Frederick Lepore of the Robert Wood Johnson Medical School, New Brunswick, in New Jersey, and Adrian Noe, director of NMHM, to analyze 14 photographs of the whole brain from the Harvey collection that have never before been made public. The paper also includes a roadmap prepared by Harvey which links the photographs of the brain to the 240 blocks and the microscopic slides prepared from them, in hopes that other scientists will use them to do follow-up research. The team compared Einstein's brain with those of 85 other humans already described in the scientific literature and found that the great physicist did indeed have something special between his ears. Although the brain, weighing 1,230 grams, is only average in size, several regions feature additional convolutions and folds rarely seen in other subjects. For example, the regions on the left side of the brain that facilitate sensory inputs into, and motor control of, the face and tongue are much larger than normal, and his prefrontal cortex, linked to planning, focused attention, and perseverance in the face of challenges, is also greatly expanded. In each lobe, including the frontal, parietal, and occipital lobes, there are regions that are exceptionally complicated in their convolutions, Falk says. As for the enlarged regions linked to the face and tongue, Falk thinks that this might relate to Einstein's famous quote that his thinking was often muscular rather than in words. Although this comment is usually interpreted as a metaphor for his subjective experiences as he thought about the universe, it may be that he used his motor cortex in extraordinary ways connected to abstract conceptualization, Falk says. Albert Galaberta, a neuroscientist at Harvard Medical School in Boston, says that what's great about this paper is that it puts down the entire anatomy of Einstein's brain in great detail. Nevertheless, Galaberta adds, the study raises very important questions for which we don't have an answer. Among them are whether Einstein started off with a special brain that predisposed him to be a great physicist, or whether doing great physics caused certain parts of his brain to expand. Einstein's genius, Galiberta says, was probably due to some combination of a special brain and the environment he lived in, and he suggests that researchers now attempt to compare Einstein's brain with that of other talented physicists to see if the brain's features were unique to Einstein himself or are also seen in other scientists. Falk agrees that both nature and nurture were probably involved, pointing out that Einstein's parents were very nurturing, and encouraged him to be independent and creative, not only in science but also in music, paying for piano and violin lessons. Falk's 2009 study found that a brain region linked to musical talent was highly developed in Einstein's brain. Einstein programmed his own brain, Falk says, adding that when the field of physics was ripe for new insights, he had the right brain in the right place at the right time. Thanks for watching this video. For more videos, please subscribe to Science News. For more details, please visit widelyexplored.com.